Hello everybody, my name is Alan, I'm from Sauber-Lab, and today will be a continue from the previous video. Basically, the previous video I told that I turned off all my server and I'm using these ones, Raspberry Pi, to run all my applications. And yes, I did it in a couple of weeks, and I have some limitations or some benefits for it, and that I will talk about it. Not only it, some people start to request me to explain, okay Alan, you tell that I need to assemble my server, and then I will, I don't know what setup that I need to do or what will fit for my needs. And in this way, I will explain a little bit more. And this first video will start with these components. CPU, if you already saw one of those, it's basically the brain of the computer, and everything will be processed for this one. And normally this one is consume most of the powers apart for the GPU. But because our server will not have any GPU or will not look for it, so these ones will be the ones that will consume more energy. In the other video, we'll explain more about RAM memory, I'll explain about hard drives, how to set up it, but first one I'll explain more for CPUs. It will be a little bit basic. If you know a lot of things, jump for another video, but a lot of people was asking about this one. So if you like this idea and want to learn a little bit more about it, we're gonna show in this video. But first of all, don't forget to leave your like, consider subscribe for the channel, and let's understand a little bit more about it. Before I started this video, let's put clear, I really like those Raspberry Pi, I have a few of those running in the house, but not necessarily Raspberry Pi fit for all the applications. Those CPUs as well, it's really recurrent for some other applications. Let's say, if I put now on the screen, I'm not to share my screen, but I will put here the screen. This one is the benchmark for the Raspberry Pi. If I look for this benchmark, they have a score for 1896. What it means? Most of the applications that you're gonna do, you need to look at this pass mark score. You don't need to look only for the how many cores or overclock, because it's relative. I will give one example. This one that I'm looking, it's Core 2 Duo. Okay, it's really old CPU. It's released in 2008, and that's they have 1172 in the pass mark, and they use around 65 watts of power. Compared for Raspberry Pi, they have less efficient for Raspberry Pi, and they will consume more energy. So if I look for this point, I will need to have at least Raspberry Pi 6 watts. I will need to have 10 of those running to justify to have one of those running. And 10 of those will run much better than this one. So this one that you need to look, only let's say pure CPU power. I'm not saying anything else. I'm not saying about RAM memory, all the rest of the setting that you did. Only for the CPU. So why I justify myself to use an old computer or a quite old CPU to do my applications instead of Raspberry Pi? No, don't justify at all, because the Raspberry Pi will work more efficient. But when you start to look for a little bit better CPUs, or what I will advise, a little bit better systems, then you have a little bit better performance. If I open here the screen, I have the pass mark power performance, where I have all the performance for different computers. This one has been done in 8th of September 2022. If you're looking in the future, maybe it's totally different. We'll have another CPU that will have low power and high efficiency. But if I look here, all the CPUs that have really low power, lower than 20 watts or lower than 40 watts, is only dedicated for laptops. And we don't want to go for this road. We don't want to buy a laptop to dedicate for my NAS. You potentially can have it. You can have a really good performance laptop. You can add extra hard drives to this laptop, and that's make it as your server, because we're not talking anymore enterprise server. We're not talking about redundancy of CPU. We're not talking redundancy of RAM memory. We are talking only about efficient and do the application, because those laptops will work for 10 years, 15 years, 24 hours per day, and without any problem. The same thing for this Raspberry Pi, and the same thing for these CPUs. That is still working. If I connect this one and leave, they will work. And those home lab, we needed to think about this range, at least around 60 watts. That will be around a CPU for a computer, and that have a little bit more efficient. And that with this one, we can look for the cost. If I open Intel Irie, I think that is a good option for most of the people consider the cost, and they released in 2022. Also, they only use 60 watts of power. It means that if I look at this score, they have around 7 times more the performance of Raspberry Pi, but they consume around 10 times more the power of Raspberry Pi. But in the same time, if you consider that each Raspberry Pi, you're gonna need to have their own hard drive, or you're gonna need to have a SSD connected to run it better. Also, you're gonna need to have this connection, the USB adapter, that will lose connection, lose power. So you started to balance and think, okay, what is come better? I needed to have a high quantity of hard drives. I don't want to have only 8 terabytes. I needed to have 20 terabytes, 30 terabytes, or 50 terabytes. Yes, you started to run out of the ports. You can make a cluster. Yes, you can make a cluster, but in the same time, this cluster will have some limitations. You can only use the MergeFS. You cannot do a RAID 5 or any kind of RAID because they don't work. So you started to put in the balance. My CPU will consume less, will have more efficiency, but I will run the problem that I don't have protection of my data, or I run the problem that I will not have more possibility to put more hard drives in the same system. And this reason that this kind of CPUs it's coming. Maybe I mis-explain. I'm moving all my system for Raspberry Pi, but I have problems. They didn't work the way that I want. What kind of applications that I want to run? I want to run my LiDAR, my sonar, my radar, and all those ones that you have 100 media for each application, they will work really well. But when you start to increase the quantity of media, then you start to have a bottleneck of CPU, a bottleneck of connection, a bottleneck of lots of other things. So instead of they running smooth and have a really nice performance and you have a really good experience, you can put to select some media that you want, and a couple of minutes they will already put to download, and a couple of minutes they already move for your location, your folder location, where you can watch it after. These don't work the same way or the same speed for Raspberry Pi, because they will need to have a SSD connect for a 3.0 connection, supposing the best way, and that in this way they will have some bottlenecks. The CPU, if you have a 2-3 application running, they will not work the same way. So it's better to have only one Raspberry Pi for each application that you already consider 18 watts, and it starts to increase the power consumption. Also, you need to have at least 3 hard drives connect for each Raspberry Pi, because if you try to do through the network, the bottleneck will be the network, 1 gigabyte per second. And that it means 100 megabytes of transfer in the best situation if they are using only one Raspberry Pi per time. If you're using 3, then it means that it will be around 330 kbytes per second. It means that around 25 something megabytes of transfer. What it's started to make a bottleneck for your Raspberry Pi, and that the performance will be reduced. At this moment, it's not interesting anymore to get old computer and make your server. It's interesting to make a new computer to make your server, your home lab. But then you're gonna ask, Alan, I have only 4 cores, and lots of people say that it's better to have more cores in my system. And you say, no, depends which kind of application that you want. Normally you look for the average benchmark. And this average benchmark, it means that if you're gonna transcode 1 4K, this one will work. If you're gonna transcode 2 4Ks, it will be quite difficult, but maybe it will work. If you're gonna run only Docker containers, yes, 4 cores will be more than enough. You don't need to go more than it. But if you wanted to make a virtualization, suppose that you wanted to have one machine work Windows, other machine work Windows Server, other machine work all your containers, and that starts to come your bottleneck. Then you need to look for a Ryzen system. And a Ryzen system have more cores, have 16 cores, or you go for i9 that have more cores as well. But then the power consumption starts to increase. If you look here, this power consumption is around 105 watts. So here I make my table. As always, it's better to compare one by other and try to understand the difference. I consider all the power consumption the same thing that they give for typical TDP for the benchmark, and the price of the energy that I'm paying, according from the internet, it's 0.36 per kilowatt hour. So I'm looking for this information. If I leave my computer 24 hours a day, 365 days a year, so in the end I will pay 190 per year. The same thing that if I look for my Ryzen, I have 16 cores, but I will pay almost double, around 331 per year. And the same thing for Raspberry Pi. If I have only one Raspberry Pi, I will pay around 19 a year. But you don't need to consider that it needs to be on 24 hours. You can configure for they start to be a little bit on for 12 hours. They start 8 o'clock in the morning when you wake up, and that's they turn off 8 o'clock in the afternoon when you stop to work, when you start to do your things. So in this way, you can reduce this price, will be half. So they will be cost 94 and 165. And maybe with these 12 hours, they can do all the applications. Or also you can have a really strong computer or a server that will do this application and move all your data for a small Raspberry Pi or a small NAS, where we'll have all your data as a main data. This reason is complicated to say what's the best option. In my view, if you look for old CPU, look like this one, forget. You don't do anymore your home lab in those, consider the price of energy. If they really go down, yes, you can have one of those, no problem at all. But at the moment with this price, it's not worth it to look for those low efficient CPU. You need to look for a high efficient CPU that give a high performance for you, because it's the balance that you need to understand. You should not look for one CPU that have 180 watts, look like Xeon CPUs. You need to look for a CPU that have a low power consumption and a high efficiency. So in this way, I give a little bit more feedback about CPUs and why you need to choose one against of the other. It's really difficult to say what exactly is the best option for me, because I don't know what application that you're gonna use. I don't know how many hours you want to keep on. I don't know a lot of things. But in general, you need to balance how much you're gonna pay for the CPU, how much power consumption that you're gonna use, and how much efficient that it will be. You don't look only for the benchmark, because normally if you look for a really high average, they will have a lot of energy that you consume and a high price to buy it. And you cannot only consider Raspberry Pi as an only solution, because it depends how much your media, or how many hard drives that you have, or what size of your configuration, or what's your needs. Raspberry Pi will be not enough. Either that you make a cluster will not be enough, because we have a lot of bottlenecks that will go in your system. So I hope that you like this video. In the next videos I will try to explain a little bit more for RAM memory, for motherboard and other things that you need to consider in order to make your server, in order to make your home server. We are not talking about enterprise in this stage. So if you like this video and think that was interesting, don't forget to leave your like, consider to subscribe for the channel, and see you next time. Bye!